We're going to take a look at a really cool situation here where we see that a repeating decimal is actually just a fraction. It's a rational number. So I'm going to show you just the non-geometric series way first, and then I'm going to show you how to turn it into a geometric series and get the fraction. So let's take a look. I'm going to actually say that this is the number set, I don't know, just capital N. It's just a set called N, and I'm going to set it equal to that. So here I have that, and it doesn't matter how many 2's I put on there. So there's that. Now, what I'm going to do is I'm going to multiply both sides of the equation by 10. Excuse me. I'm going to multiply both sides of the equation by 10. And let's see what happens. What happens when I multiply that whole number by 10 is that one of the 2's comes on the other side there, and then I have a bunch of 2's, right? Continue after the decimal. So I'm free to do this. I can take two equations and subtract them. Well, I'm going to do that. So I have 9n. When I subtract this, I start from the right. All of the decimals, all of the repeating decimal part goes away. They subtract from each other, and I just get a 2. Well, now I'm going to divide by 9 to get the n alone, and my actual value, n, is really just 2/9. So if you go to a graphing calculator, or any calculator, and you press 2 divided by 9, you're going to get the decimal 0.2 repeating. Pretty cool, huh? Now, let's take a look at doing this same exact problem using the formula for an infinite, that was a little bit sloppy, the formula for an infinite geometric series. So I'm going to rewrite this thing as this, 0.2 plus 0.2 times 10 to the negative 1. In other words, the next one in line would be, this right here ends up giving me 0.02, right? 0.02. So, in other words, I'm just adding the next smaller fraction, basically. So let's go ahead and put that one down. And then we have 10 to the negative 2 plus 0.2 times 10 to the negative 3 plus, and it goes on to infinity. So there's my series, actually. There's my series that really does turn into the repeating decimal 0.2. So let's look at this as an infinite series, and here we go. So what is my A? My A is 0.2. My R is 10 to the negative 1. In other words, it's just a tenth. Because if I look at the difference between this one and this one and this one, it is a tenth. Okay, so we know that it's going to have a sum because my common ratio, absolute value, is less than 1. So I really only need those two pieces in order to put together the sum. So let's take a look. The sum of an infinite series is the first term over 1 minus the common ratio. So let's see what we get. We get 2. I'm going to change that into 2/10, that fraction 0.2. And then I have 9/10 at the bottom. Well, I know that the 10's are going to cancel when I invert and multiply, and so I'm going to get 2/9. That's exactly what I got before. Pretty cool, huh? So it's basically a geometric series, infinite geometric series. Let's take a look at what we would do if we have two places that are repeating. Well, it's really similar to the other process we used. I'm I'm going to go ahead and start like this. And then I'm going to, instead of multiplying by 10, I'm going to multiply by 100. And why is that? Because I want the whole thing that repeats to be placed on the left side of the decimal. So I'm going to go 100 in. So that's going to give me 17.17, and on forever. Okay, so let's take a look. I'm going to subtract, and I'm going to get 99n is equal to 17. You know what we're doing already, right? Divide by 99, divide by 99, and I get that n, in other words, the very same thing that I started with, is n, is really also equal to 17/99. Okie doke. All right.